right? He must have the apply his mind, whatever his mind says, according to the intuition, he must work on that. And then connection between the points, mind mapping, we used to say that is right, mind mapping, connecting the points, dots, connecting the dots to find the solution, right? Out of the box thinking, right? Not kind of stereotyping, he must work hard, right? Whatever the possible ideas that might be not in line with the existing. Still, if you got that, you should not worry about that. You should not have fear about that, right? You should have the courage. You should have the courage, right? Test it. Try to prove that your idea will work on, right? The last point you see, this is what always used to insist to my students. Enlightened mind, I used to say open mindedness. Open mindedness. What is open mindedness? That means you should be open to any idea. You should not have any boundaries, right? For that, you must be physically and mentally fit. Physically and mentally fit. Sir, in what way the physicality is coming here? We are discussing about innovation, R&D, right? What is the need for this physical fitness? If you are not fit physically, you cannot think. Your mental strength won't cooperate, right? So, in order to have that open mindedness, the guy who wants to innovate, he must be physically and mentally fit, right? That definitely helps in his R&D sets, right? So the first point is curiosity, thirst for learning. Ask questions, whatever the thing, whatever the problem, you just throw the questions. What for this? Why this method? What will happen if I use another method? How I should do that? If I change the material, what will happen? If I change the material to change the composition material, what will happen? Right? Just throw the questions. Try to find the possible solutions. Then definitely will crack. For that, you need the fundamental technical knowledge. Enrich your technical skill and then apply in your mind so that you can get the idea. Right? Demonstrate. Whatever in your mind, visualization, everything is okay. Apply that. Practically test. Check. Physically sense how it works. Right? Then you will have the vision to identify, to find the solution. Right? Keep on learning. Sharpen the senses. Right? There is a technical term we use in TQM, Total Quality Management, that is continuous improvement. There is always changes. There is always new technologies coming in, right? Used to be technologically advanced. Okay, so that there is no end for learning, enriching the knowledge. Keep on learning, continuously improve yourself, compete with the market. Then only you can sustain, right? And be comfortable with the ambiguity, right? So ambiguity, yes, definitely that must be, but for that to confront all those, you must have the confidence, right? Out of the box thinking we are saying, right? For that to understand, to apply that, you must have that confidence to work on that, right? So you must have that balance between the logical and creative thinking. Simply without any logic, without any scientific background, you cannot say, you cannot prove your concept, right? You must have the scientific background. Then only you can think wisely, right? This is what we discussed. You must develop your coherence between your body and mind. Right? Try to work whatever in your mind. Try to make it in black and white, right? A schematic, simple schematic. Make it in a picturized view so that you can see the patterns, relationship, that you can understand what are all the factors, influences, how it affects, how it can play around with the variables, right? So for that creative thinking, there are a number of mental blocks out there. Mental blocks. What are the mental blocks? You may see, right? The poets or the story writers, Even for movie, right? Movie story writers used to go to some hill stations, Himalayas. They stay alone, right? That means they won't allow some environmental factors affect their thinking ability, right? That is the key point. You should not deviate. For that, you might need some environment. Then your colleagues, your surrounding peoples who motivate you, stay away from them because they want to force their idea in your mind. Their negative attitude in your mind that will pull away, right? You will get deviated. So that please keep your environment stress free, will help, which motivates you, right? Right. And then tactical issues. Tactical issues is, stereotyping used to say that you would have number of already proved methods. People always suggest, why don't you use that method, this method? They won't allow you to innovate new. They always correlate with whatever you are proposing. They used to correlate with your new, with the other one, right? So that leads to some existing methods, right? Right. So you have to work on, and you have to work on continuously till you achieve your goal, right? So that's you must have some regular follow. You must work on that, right? Personal blocks means lack of confidence. When you would have how can you improve your confidence level? How can we improve our confidence level is we must in very small problems try to find the small solution for the small problem. You will get success. That will motivate you, that will guide you, that will give you some kind of confidence. That will be helpful for us to climb the big ladder, right? Should not worry about that failures, right? We can avoid that. Yes, definitely. Big failures we cannot afford because of the time involved with that development of the product or the cost involved with that product. Yes, of course. But for that we have a number of methodologies to check whether our idea work or not before implementing into our product. Right. We all hear this word, eureka, eureka, eureka. The famous Archimedes. We hear that story, right? While he took his bath, he ran away without any claws, right? Shouting, eureka, eureka. That is, he found the relation between the density, mass, and volume, right? Do you think that it is that innovation or invention he found mysterically, or with a flash he got that idea? A lot of people think like that like a flash they will get a idea for a new product in innovation. Never happen. It won't happen. It's not at all possible, right? So in order to get that kind of innovation, you must work on that. Then only that strikes 24/7. The person who is in R&D think about that problem. Whenever he supposed to come across some kind of related solution, he will have that ability to correlate how to use that technology or this method to his problem, right? To solve all those things, right? It won't be just by like a flash of fire or something like that. It's a continuous work, applying his mind in that problem 24/7. Then only we can get that idea, right? So this is the innovation, new product development from the early stage to finished stage. This is the complete slide which shows you, right? Whatever the product we are developing is for the customer. First point, you are proposing a product to be developed. That product must have potential demand in the market. Otherwise, there is no need to manufacture that product. There is no need to develop that product. Right? First understand. Whatever the product is we are manufacturing is for the customer. If there is no customer to purchase your product, there is no need to manufacture the product. There is no need to develop that product. So the starting point, initial point is from the customer. Right? Then we must understand what are the related products available in the market. How deep that penetrates into the market. Can we develop a competitive product and still can we manage that product to sell into the customer? Is it possible? For that, we must have some catchy idea to attract the audience or the customers towards your product. Right? So from there, I will get that innovative idea. Again and again, I'm saying that innovative. Sir, where should I get that innovative idea to develop a new product? Existing R&D, you might have some kind of R&D with you, or new publications, literatures you can get, or you'll have some kind of existing team, like sales people or marketing people who are in direct contact with the customers. From them, you can understand where is the gap, what is the market demand. The service people know how the parts are failed, how miserable, what the customers are exactly looking for. He will say. So normally, these are the normal two methods we get the product idea. One is from our own people or from the R&D. Then they used to have brainstorming session. Brainstorming session means top to bottom peoples with all department, technician to the VP Vice President, all sit together and they throw their ideas to develop the product to fit into that gap available in the market. Some of the ideas may be meaningless, but in that brainstorming session, all ideas are welcome. Some ideas might not be never possible. Yes, welcome. No issues, welcome. List out all the ideas in black and white. Write every idea suggested by the peoples. Because you see why this brainstorming is important in innovation is previously especially our cultural block, mental block is this, that the junior fellow can't speak even to the manager, even to the hierarchical manager, he can't open his mouth. Recently, I saw an interview where Ratan Tata said this, all the same thing. The early career of his engineering, he himself cannot say. The boss will say, that is his immediate higher level, will say, what's your experience? Do you know my experience? How dare you to open your mouth to me? What do you know about engineering? So this kind of questions they used to throw on you. They will kick you out of the discussion room. That was the previous gen. Nowadays, you know what is happening here? They call the younger most people, bright young. just completed engineering student, they ask, what's your opinion? What do you think about that? He will randomly say whatever in his mind, but that might help. That might help. Each and every idea is very precious, right? So nowadays the scenario is changed a lot. Now all ideas are welcome, right? Then whatever the ideas we are having in the table, list out, rank that. For that, a lot of tools are there, technical statistical tools also there. Feasibility, whether we have the provision, we have the ability to materialize the product. We cannot invest billions and billions of money, right? So wisely they think over that. Next level meeting will go on. They prioritize according to the priority. They list out the ideas, and after that they would go to the development phase. Modeling, we all know 2D modeling, 3D modeling, detailed drawing with bill of materials, different materials, availability of materials, what is the tolerance level, complete draw, complete, right? All kind of suppliers, inventory, right? Our layout, everything will be checked, and then they develop. And then prototyping. Previously, what they do, they physically test. They develop their product and physically test, but that require much time and cost to physically test, right? If you take, I have some videos also, I'll show you. Car crash analysis. How many cars you would have crashed to check the passenger safety, right? This is not at all possible. You know, hitting the car with a motorbike is different. Hitting a car with a different velocity, that means speed, is different. Hitting the car face to face, collide with each other is different. Hitting the car with respect to some kind of concrete is completely different. Steel is completely different. Rollover is completely different. Different angles of attack. Completely scenario is different. Right? So before going to that experimental testing, nowadays we have that RPT, rapid prototyping facilities, where normally prototypes, scaling models we test. Nowadays, the additive manufacturing helps a lot. Very fastly we can develop the model and analyze, right? But before that, now mathematical modeling is getting very popular. MATLAB or FE techniques or CFD techniques, right? Numerical simulation, right? So that helps a lot. Nowadays, in industry, now the current scenario is while float their tender, they asked to submit the numerical analysis results. Railway, whatever the department, they used to tender, right, their product for the design and development of product. They asked the suppliers, contractors, numerically simulation results to validate their design. Then only they evaluate the design is okay. Then only they give order. Now it is customary. Very recently, almost ISO, all the industries adopt this method, numerical methods, right? Okay, so we can save huge amount of money and time involved with the prototype testing. So once we got that confidence over that developed product by means of numerical simulation results, then we can shift over to the check with the experimental prototyping models. After validating with the prototyping models with sensor, database system, everything and all, that would take some time and cost also. Okay, definitely before launching the product, we must experiment all the worst case analysis, right? Endurance analysis, whatever it may be, fatigue, loading, different temperature, whatever, where you can expect your product to be exposed, right? Based on that only, you are going to give your warranty, guarantee, everything. Whether your product into this much time. Without that, how can you give that into warranty and guarantee, right? So that should be done by means of experimental analysis. Much important, right? Then you will have the proved model with you that has to be manufactured according to the original size material, and then that has to be tested again, and then the product has to be launched. So this is the complete new product development, right? Fine. After launching, if your product fails, you can't survive in the industry, because normally it will take 2 to 3 years, or it may take much more time, depends on the product, right? So you are investing that much money, that much time to develop your product. But if you are not able to satisfy the customer requirement, you cannot sustain. At the meantime, you have to price your product competitively with respect to the market. Otherwise, nobody will going to purchase your product with the same quality. Depends on the quality. I use that quality word. We have the Tata Nano car for 1 lakh, 1.25 lakhs, and Rolls Royce car for 12 crores, right? Depends. Money involved with the quality, involved with the customer demand, right? Where you are going to position your product in the market. That is much important. That also you have to think about that. Where I am going to position? Who is my customer? You must have that idea. To introduce your product into the market, then it will be very difficult to compete with the existing products. If a product is the first one, definitely your success rate must be very high, right? You might have heard that story of you may be experienced. All the faculties might have experienced this, right? The story of Nokia. In our college days, our age stage, like 20 years back, used Nokia. That much strong player in the mobile industry, right? Very good quality product, but still they are not in the industry right now. What happened? All because of the change in scenario, technological advancements. They are very reluctant to change. That's the problem. I said one word, right? Continuous improvement. Right? So keep on working to improve your product. Though you are 90%, yes, you are 90% is a market stakeholder. Okay, fine. See, now where you are. Okay, so market will change abruptly at any time. You should be vigilant. You should work on that. That is what the technical term for that is agile manufacturing, lean manufacturing, agile manufacturing subject is there. Agility. So the market is volatile. We must be in the position to change according to that very fast. How fast I can adapt to the changing market. The car manufacturer, you can see, they first develop their product, they launch their product as fast as possible. And then they will give, every year they used to give some updates, version 1, 2, 3, 4. Every year they used to give some updates. They find some kind of, okay, these are all the problems we can change. Why don't they do all the improvements in the first stage itself and then introduce their product to the market? They cannot compete. Some other players will run away with their profits. You cannot enter later. That's the problem. So we must try to be the first one to enter the market. So why I'm insisting that much is, if you take this idea generation to make that as a product, if you take much more time than other competitors, you will lag behind. You won't be in the race. That is the point I'm coming to say here, right? So for that you must be very fast. Very fast, right? For developing this product, right? So this slide shows you what we discussed so far, right? So idea generation is coming from three ways. One is from the technological advancements, one is from the R&D, one is from the customers. From the customers, you can identify what are the demands, what are the needs of the customer. From that, you can develop your idea. State of art is nothing but the literature in the technology and production, innovation, whatever it may be. You can adopt the latest advancements in your product, and you can do that, right? So in your applied research, you will do the basic research and applied research and develop. This is the point we discussed, right? Conversion of idea into a potential sellable product. You have the idea, but you cannot commercialize, means there is no meaning of innovation, right? Right. So what is the consequences by your innovation? How the social system or individual is going to change, how it influences the life of the customer. Right. So that innovation adoption process, we have some kind of steps. You can see the stages. First, we must have that awareness. The R&D or innovator must have that awareness, exposed to that innovation, but maybe he might not have that complete information about that, but he might get that awareness, right? So that individual is interested with that idea and he wants to study more on that, and he requires more information over that. So he looks around the literatures and find, and then he apply, right? He tries, develop his model, right? Evaluate whether it works or not. If it have the some kind of working confidence, he will go with the different trials. If the trials works better, right, it gets more accuracy, what you expect, then it can be adopted for the innovation. So these are all the stages in the innovation process. Okay. For that, they are ready to provide you funding, not for the basic. Now the scenario is changed, right? So we must be aware, right? So you have some kind of idea, right? You have some kind of idea, innovative idea in your mind. You want to develop that as a product. But in between, we have these much steps. 9 steps are there, right? You see, you can see in detail, right? So TRL 0 is nothing but an idea, nothing but a line. You didn't know anything else other than that your idea. You don't have any other information about it. TRL 1 is a basic research. This means without any experiment, you will do some kind of research. Technology formulation, right? You prove, right? Your basic research will work on that. For that, we can say that as technology formulation, engineering sense. We can say that as an engineering sense. Mathematical models, 3D models, simulation kind of, all this can be used, right? Applied research is nothing but proof of concept. Proof of concept means lab level testing. Proof of concept is nothing but lab level testing. There you can prove that your idea will work, your concept will work. That is coming under the applied research. And then the TRL 4, where you can see small scale prototype. That means not the exact kind of prototype, small scale prototype, right? Again, you can see that ugly prototype means not exactly some kind of prototype which demonstrates how your product will work, right? Yeah. Not in the intended environment laboratory. Then TRL 5 is the large scale prototype, right? So this is environment. And then TRL 6 prototype system. Prototype system is as close to the exact product. TRL 7 demonstration system. So where you should demonstrate your product to the potential worst case analysis. You have to prove that your product will survive at any circumstances. And then TRL 8 is the commercial system, that is manufacturing. The final product manufacturing. And then TRL 9 introduced to your product to the customer. Now you can understand the complete technology readiness levels. So there are TRL 9 stages are there, right? You have some kind of innovative idea, and you first what should you do? You should file the patent on your innovative idea. File the patent. Sir, I don't have any prototype or any hardware. I have only the idea. Then you can provisionally file your patent, and then they will provide you some time, that 6 months, or you can take at least 6 months to develop a prototype, and then you can submit your patent. Before patent, do not reveal your innovative idea to anyone. You won't know where it reaches, right? So try to file the patents as early as possible. Even an idea can be patented provisionally. It will be protected, right? Fine. Right. This is what we discussed, technology readiness level. Right. So how we can convert, because what I put this slide here is, we are all from the academic background. We don't have any kind of industrial collaboration or any kind of exposure to industry. How can I market my product? How can I sell my product? We'll get that question, right? Definitely. How can you sell your product? Your idea, how can you convert your idea into a product? How can I take that as a marketable product? How can I reach the customer? Right? So we need kind of industrial support. For that, before going to the industry, what I suggest, apply for that patent, and then connect with some kind of industry, collaborate with them. Before that, you develop your idea into some kind of prototype, right? So we used to say that the first TRL is 3. 1, 2, 3 is what up to what we normally academic people used to do, right? Beyond that, we are very reluctant, hesitant. We don't have that confidence whether we can convert that idea into a product, because we won't have that facility also, manufacturing facility and all. For that I said, right, for that additive manufacturing is a gift to us. You can easily visualize how your idea, how your drawing can be converted into a product within a day, with very cheaper cost. That helps a lot, right? So normally the academic peoples, we develop our product up to the technology readiness level 1, 2, 3. Up to that we used to stop. But The technology development is coming after that only. 4, 5, 6. That is development of, first of all, mathematical modeling, and then prototypes modeling, and then testing. So whatever you suggest your product, you can draw. We have, you all know, we have the softwares to develop our drawings and all. We can visualize, right? We can check for their ability to withstand by doing some kind of finite analysis. If it is involved with some kind of flow, we can do some kind of CFD analysis, computational fluid dynamics, whatever possible ways that we can do with ourselves. As an academic person, I can say up to that at least we should have completed. If you have that results with you, you will have that confidence that your product will survive, sustain in the market. Then if you got, you can pitch your idea to the industrial peoples, and then you can market. You can sell your idea, or you can have partnership with industrial persons, or you can attract some kind of investments from industry. There are a number of financial providers are there, angel investors, we used to say. You can use their thing, and you can apply for funding from government agencies also. DST, a number of funding agencies are there for entrepreneur, for startup, and even for academic peoples. We have the funding agencies, we can knock the door, and we can get the fund for development of products, prototype, and testing the prototype, so that we can develop our own product. See, why I again and again saying that before going to the prototype, do some kind of mathematical modeling, numerical simulation, right? So these are all the test analysis can be performed in our lab, in our CAD lab with our ANSYS software or any kind of numerical simulation software, right? This can be done by ourselves, right? We can use our student strength also. You can train them, right? See how many, there are thousands and thousands of possible ways of collision of car crash. You just look at this. The right one is the side collision, left one is the straight to straight. You see, straight to straight with a different angle will provide different results. Straight to straight with different weight will yield different result. Right? Side collision will yield different results. Collision with the steel bar will yield different results. Collision with concrete will yield different results. So there would be thousands of experiments. If without mathematical modeling, it is not at all possible to do all kind of experiments. Believe me. So first of all, we should complete all the experiments with the numerical simulation. Right, come to some conclusion that these are all the variables will work fine. Stick on to that, and then you develop their prototype and then test. So you might have over this global NCAP results, right? European standards, 5-star rating, 4-star rating. All right, these are all the physically tested. Which takes, just think about that. How much crores and crores of money is involved with the testing of car crash physically, right? So environmental testing, your car has to survive in any environment. You have to test, right? So for that, you might out look this, right? Camouflaged cars roaming around in our streets. Right, because they say that their car engine will survive up to 5 lakh kilometers. They have to run, not in the lab, in the real roads, in the deserts. That should not have some cold start problem, right? Your car is going to be in Himalayas. The oil viscosity should not change. It should survive. Fine. So similarly, we are running out of time. I try to complete as soon as possible. So manufacturing readiness level is similar to that. Our manufacturing ability to manufacture the proposed product is known as manufacturing readiness level. According to that, we can identify which stage we are. So whatever we have in our lab should be commercialized. That is what I focus on today. Right. So technology transfer, whatever be technology that has to be transferred to make it commercialized with the industrial partner. Right. So before that, I request everyone to please don't forget to file your innovation in the patent office. Right. So this is that my request. There is a huge potential for this innovation economy. I hope we too is going to lead the globe in this area also, right? In the innovation R&D area also within near future. For that, as an academician, we must have that awareness about that innovation and filing the patents. So I request all the faculty members who are joining here to give awareness about this innovation to your young minds, students, and convert their projects to your patents. That will help to their job opportunity also, or they may they can become as an entrepreneur, and you too can become an entrepreneur. Wish you all the best. Thank you. Any queries you can ask me right now. Sir?
Sir?
Yes, sir. Yes, please.
Hello, sir.
Yes, sir. Please, sir.
Sir, could you please display your email ID, sir? I am Jocelyn Herbert.
Okay. Oh, just a second.
Okay, sir.
So you can reach me by mail m.starvin@gmail.com.
Okay.
And to my mobile number 9486865043. You're always welcome for any kind of R&D discussions.
Okay, sir. Very nice discussion, sir. I will call you later, sir.
Sure, sir. Thank you, sir. Thank you so much.
Thanks.
Participants can ask your query now to them. Okay, sir. Sir, thank you very much for your.
Thank you, R. Monaina, sir.
So now I request our Professor Mr. Ganesan to give a vote of thanks.
Good evening, sir. Good evening to one and all. First of all, we sincerely thank to our today's guest, Dr.M.S.Starvin, sir, Assistant Professor, University College of Engineering, Nagercoil, to give the wonderful knowledge to us in the various collection of areas. The Dr. M.S.Starvin sir focused the topic of new product development. So I hope this topic and the sir presentation very useful to us and our various college faculty members to develop and to do innovative research work and to apply patents in upcoming days. It's very useful to us. Thank you, sir.
Thank you, sir. Thank you so much.
Next, we thank various college faculty members to spend their valuable time to this lecturer and to give more attention in our faculty development program. Thank you, all college participants. Then I would like to thank our Reverend's father, our administrator sisters, to grant the permission and to do this session, this FTP, a very successful manner. Next, I thank our principal, Dr.M. Rajkumar sir, to provide the valuable suggestions and to give permission to do the full-fledged work. Next, we thank our head of the department, Mr. R. Siddharthan sir, and our none of other, our coordinator, our FTP coordinator, Dr. M.R. Muganainar sir. His presence in this FTP schedules and the timing and video link, audio link, and YouTube lives, they concentrate more effort to this FTP. Very thank you, sir. Next, I sincerely thank our JP College of Engineering Department of Mechanical staff members and our colleagues to do this event very successful manner. Once again, I thank you all to give your valuable attention in this FTP. Thank you, sir.
Thank you, sir. Thank you, everyone. Once again, I thank the team behind the screen of this FDP, Dr. R. Muganainar, Dr. Ganesan, and the head of the department, Siddharthan, everyone, for giving me the opportunity to share my ideas with you. One request I can say that I'm going to conduct one FDP on additive manufacturing. I share the brochure with Professor R. Muganainar. If anybody interested, you can join. There is no registration fee. It is a physical mode 6-day faculty development program sponsored by University Chennai, which is going to be organized at University College of Engineering, Nagercoil. If people who are interested, you can join with us. So all the best. Thank you, sir. Once again, thank you so much.
Thank you, sir.